Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. This college is affiliated to Maths University, Rohtak. Today our topic will be triple integration and triple integration in Cartesian form is it in your syllabus. So triple integration, before triple integration, I just want to discuss center of gravity in arc, right? And two or three more examples related to triple integration, right? So I told you center of gravity in the form of x and y in our previous session, and today this is our center of gravity of the arc of the curve. If it is curve is given like x is equal to a theta plus sine theta and y is equal to a 1 minus cos theta. So basically, if our curve in the form of theta and r, it means polar form. So our center of gravity formula will be x bar is equal to integration x ds upon integration ds, and y bar is equal to y ds upon integration ds, right? So this will be your center of gravity of an arc, right? Now ds, what is ds? Ds is equal to square root of dx upon d theta whole square plus dy upon d theta whole square d theta. So this is your ds, right? Now find the center of gravity of the arc of the curve x is equal to a theta plus sine theta. So we need to calculate dx upon d theta and dy upon d theta. So just calculate dx upon d theta. So you can see that a sine theta differentiation cos theta, theta differentiation 1, and dy upon d theta, a 1 differentiation 0 and cos theta differentiation minus sine theta. So minus minus will be positive, so we have a sine theta, right? Now put these two values in equation ds 1. So ds is equal to square root of a square 1 plus cos theta whole square plus a square sine square theta and d theta, right? Now a plus b whole square. So a square plus b square means a square cos square theta plus 2ab, that means 2a square cos theta plus a square sin square theta and d theta, right? Now you can see here that after solve this equation ds is equal to a square plus a square. So a square cos square theta plus a square sin square theta you can write together. A square is common, so cos square theta plus sin square theta is 1, and after solve this you are getting ds is equal to a 2 plus 2 cos theta and d theta. So a is your outside and 2 1 plus cos theta. So cos 1 plus cos 2 cos theta, so you can apply here cos 2 theta formula. So cos 2 theta, we know that 2 cos square theta minus 1. So cos theta, theta means theta 2 theta is dividing by theta. So theta will be theta by 2 here. So a 2 square root of 1 plus 2 cos square theta by 2 minus 1. So minus 1 minus plus 1 cancelled out. And you have ds is equal to 2a cos theta by 2 into d theta. Right? Now we have ds. So just write the value of ds in x bar and y bar. So x bar is equal to integration x 2a cos theta by 2 d theta upon 2a cos theta by 2 d theta. Right? Now limit is 0 to pi here, right? Because a x is equal to a theta plus sine theta, y is equal to a 1 minus cos theta. So after solution solve these two equations, so our theta will be 0 to pi, that means it is in the positive quadrant, right? So arc center of gravity in x-axis, so 0 to pi. So limit theta limit is 0 to pi here in the positive quadrant, right? Now 0 to pi a theta plus sine theta 2a cos theta by 2 into d theta upon this integral, right? Now integrate this function. So for the integration of this one, a square 0 to pi after multiplication is inside the bracket here. We are just multiplying inside the bracket, and we can see that a square 0 to pi 2 theta cos theta by 2 plus 2 sin theta into cos theta by 2 into d theta. So a square is common, so just cancelled out. So 1a will be here, and upon this is also. Now just write 2 or 3 more step here. So 2 theta cos theta by 2 d theta plus 0 to pi, this equation, and cos theta by 2 integration is 2 sin theta by 2 0 to pi. Now for the numerator, integration of the numerator, consider theta by 2 is equal to t. So d theta upon 2 is equal to dt. D theta is equal to 2 dt here, right? Now when theta is equal to 0, so t is equal to 0 when theta is equal to pi. So your t is equal to pi by 2 because limits are 0 to pi, so limit will also be changed. Now put all these value here, then you can see that a 0 to pi by 2, 2 into 2t cos t 2 dt plus 0 to pi by 2, and this value also be here. In new denominator you have applied uh, limit, so 2 and 1 minus 0, so you will get 2 in your denominator, and in numerator t cos t dt plus 4 0 to pi by 2 sin 2t, you can write 2 sin t into cos t dt, and t cos t dt plus 2 sin t cos square t into dt. Here integration by parts rule will be applicable. That means first variable as it is, integration of second, so cos t integration sin t minus differentiation of t is 1, integration of cos t sin t, and again integration. Limit is given 0 to pi by 2, plus in second integral we are considering cos t is equal to p, so minus sin t dt is equal to dp. So 4a t sin t minus sin t integration is minus cos t, so minus minus will be positive, 0 to pi by 2 plus 2 into 2 4, a is also here, and sin t dt you are writing minus dp, and cos square t, that means p square here. Okay, here p square, right? This t square is not here, there will be a p square because we are considering cos t is equal to p. Now 4a upper limit minus lower limit, so pi by 2 sin pi by 2 minus 0 plus cos pi by 2 minus cos 0, right? Minus 4a p cube upon 3 and 0 to pi by 2. Apply here also upper limit minus lower limit. So 4a pi by 2 sin pi by 2 is 1, cos pi by 2 0, minus cos 0 is minus 1, minus 4a upon 3 cos cube t is given cos t. So it will be cos cube t 0 to pi by 2, and you are getting 4a pi by 2 minus 1 minus 4a upon 3 cos cube pi by 2 minus cos 0. Just solve this, and we have 4a pi by 2 minus 1 minus 4a upon 3 0 minus 1. So after solution you can get x bar is equal to this one, right? Now y bar is equal to integration y ds upon integration ds. So 0 to pi a 1 minus cos theta 2a cos theta upon 2 into d theta upon this one. So again you can see that cos theta by 2 minus cos theta into cos theta by 2 upon this one. So just solve this. You can write this equation 1 minus cos theta as 1 minus 1 plus 2 sin square theta by 2. Why we are doing? We are doing just deleting 1 here, uh, so that our integration will be easy. So 1 minus 1 plus 2 sin square theta by 2 into cos theta by 2 into d theta. So 1 1 cancelled out here, and 0 to pi 2 sin square theta by 2 into cos theta by 2 into d theta upon this one, right? So we can see again here that if we consider sin theta by 2 is equal to t, so our cos theta by 2 is here. So in denominator same as it is, no change. In numerator, we are considering sin theta by 2 is equal to t. So half cos theta by 2, d theta is equal to dt, and cos theta by 2 d theta is equal to 2 dt, right? Now, so t squared dt here, so 2a t cube by 3 0 to pi, and t is given 2a upon 3 sine cube theta by 2 0 to pi. So 2a upon 3 sine cube pi by 2 minus sine 0. So 2a upon 3 is your second center of gravity here. Now we have our all center of gravity x bar and y bar. So just write your now, our second topic is triple integration. So, triple integration, same as it is as double integration, but here limits will be 3 and our variable will also be 3 here. So, it is denoted by triple integration as fxyz ds, right? So f is a function of x and y, x, y, z. It can be calculated as integration z1 to z2, y1 to y2, x1 to x2, fxyz dx dy dz. So here, if you're writing first limit z1 to z2, so your integrand will be dz here. If you are writing y1 to y2, so your integration going with respect to second integration. And in last one, outer integral is x1 to x2. That means your outer integral will be with respect to x here, right? All these limits can be variable, or no, only two limits can be variable and all the three limits can be constant here, right? But last one, outer limit, always be constant, right? So first, we integrate with respect to z, treating xy as constant between the limits z1 and z2. Then integrating with respect to y, keeping x as constant between the limits y1 and y2. And at the end, we integrate the resulting with respect to x within the limits x1 and x2. So as our integrand given, same we will follow the procedure. That means what is the order is given, then same we will follow the same order. That means first z is given, so with respect to z, y is given with respect to y, x is given with respect to x, right? Now the triple integration x plus y plus z dx dy dz, where r means reason is given 0 is less than or equal to x, less than or equal to 1, 1 is less than or equal to y, less than or equal to 2, and 2 is less than or equal to z, less than or equal to 3, right? So we can see that triple integration dx dy dz. So our limits are given dx dy dz. That means z is given 0 to 3, 1 to 2, 0 to 1. So after writing the limits, we can see here that 2 to 3 limit is related to z. So our integration with respect to z here. So x 2 to 3 dz plus y constant 2 to 3 dz plus z variable, so z dz. After integration this and after applying this the limits, you can see that x upper limit minus lower limit plus y upper limit minus lower limit plus half upper limit minus lower limit. So you are getting the solution as this line, right? And also d by dx is here, here d by dx, right? Now 0 to 1 dx dy. So 0 to 1, 1 to 2, x plus y plus 5 upon 2 dy dx. So integration with respect to y. So x is a constant, so just write this step and after integration and apply the limit. So upper limit minus lower limit, upper limit minus lower limit, and here also upper limit minus lower limit, right? Now x plus 3 by 2 plus 5 upon 2, you can write it x plus 8 upon 2, and you can write it x plus 4, 0 to 1 integration. Now with respect to x integration, so 0 to 1 x dx plus 4 0 to 1 dx, so x square by 2 plus 4x, apply limit. So your final answer is 9 upon 2, right? Now here all the limits are constant, so you can integrate first with respect to x, after with respect to y, after with respect to z, doesn't matter. First, if you want to differentiate first with respect to y, so you can go for this, but all the limits is are variable here, so it doesn't matter what is your order. But if the limits are variable in the variable form. Here the limits are in the variable form. So you will see that which variable is coming first, which variable is coming after that, and also after and after that, right? So you can see here that last outer limit always a constant limit, as I told you that outer limit always a constant limit. So 0 to log 2 is a constant limit, 0 to x and 0 to x plus log y. So you can see that dz here, that means inner integral is going with respect to z. So limit of z is equal to 0 to z is equal to x plus log y. That means z depends on x and y depends on only on x, and x is a constant. So our order is right here. So e to the power x plus y, you can write it outside, and e to the power z integration with respect to z. So 0 to x plus log y, and same as it is in e to the power z, and 0 to log 2, 0 to x, e to the power x plus y. Apply limit here, so upper limit minus lower limit dy dx, right? Now 0 to log 2, 0 to x, e to the power x plus y. You can write this equation as e to the power x plus y. You can write it e to the power x into e to the power log y minus 1, e to the power 0 value is 1, dy dx. Second integration is going with respect to y here. E to the power log always 1, so it will be y here. Now, just to solve these two or more three steps, so 0 to x, you can write this e to the power x into e to the power y, e to the power x into y minus 1 dy dx, and 0 to log 2 e to the power x, 0 to x e to the power y, e to the power x y minus e to the power x. Means what we are doing here, just multiply y inside the e to the power y, right? Now e to the power x is here, y into e to the power y dy minus this e to the power y dy and dx, integrating with respect to y. So applying integrating by parts rule here. So y e to the power y means first as it is, integration of second minus differentiation of y and integration of e to the power y, and again integration, and limit is 0 to x here. This is also integrating with respect to y. Now apply the limit. So this one as it is, this one as it is, x e to the power x minus 0 will be here, minus e to the power x plus e to the power 0, and this also here, right? Now, after solve these two steps, e to the power x, just multiply inside the bracket, and you will get your final this line. Now integrating with respect to x. So apply integrating by parts rule here. So x as it is, integrating this one, minus differentiation of x is 1, integration of this one, and again integration 0 to log 2 minus this integration is this one, and this integration is this one, right? Now, okay, here x e to the power 3x upon 0 to log 2 minus this integration is again happening, so e to the power 3x upon 9, and the same as it is. Now apply the limits. So after applying the limits, 1 by 3 log 2 e to the power 3 log 2 minus 1 by 9, and we are just applying upper limit minus lower limit. So we can write this one as 2 cube log 2 cube means n log m. You can write log m to the power n, and after this, after solve this equation, log 2 and into 8 minus something like that, after the calculation you will get your final answer, right? Now there is another question here. Evaluate triple integration x square plus y square plus z square and dx dy dz, where r denotes by the reason bounded by these lines, right? So lower limits are given, x is equal to 0, y is equal to 0, z is equal to 0. So we need to calculate our upper limits, right? So for the upper limit, there is a plane here, x plus y plus z is equal to a. So z is equal to, you can have a minus x minus y. So this is your z. Now upper limit of z is here. For the limits of y, so for the limit of y, you will put z is equal to 0. So y is equal to a minus x. And for the limit of x, you will put y and z both 0. So you have x is equal to a. Now just write all these limits here, and first integration with respect to z. So just integrating with respect to z. So x square z plus y square z plus z cube upon 3, and limit is 0 to a minus x minus y, right? Now apply the limit here. So after applying the limits, you can see this step, just x square multiply inside the bracket, y square multiply inside the bracket, and this step same as it is. Just solve this equation, and integration is going with respect to y. So here ax square dy, so y x cube y x square y square upon 2, this and this one. After applying the limit, so this step is happening here, and solve this step, and you can see that there are more calculation here. So lot of calculation, just again integrating with respect to x, and after applying the limit, so your answer is a to the power 5 upon 20. So you will solve this question, and just apply all the limits, three limits: first integration with respect to z, second with respect to y, and third with respect to a, right? And your final answer is a to the power 5 upon 20. So just solve this question, and there is an exercise here. Okay, this is your exercise, so you can solve all these questions, right? There are total 24 questions here, so you can solve all these three questions. If you have any doubt, then you can ask me, right? So solve all these questions, you can see, right? And in our previous session, I will share uh, surface related questions and volume related questions, right? And after that, I will share vector calculus, so Green's theorem, Stokes theorem, and Gauss divergence theorem, right? Okay, thank you.